Finding displacement, velocity, acceleration graphically, we had learned that the slope of displacement time graph gives us instantaneous velocity and slope of velocity time graph gives us instantaneous acceleration. On the other hand, if we want to go in the reverse direction, we use area under the graph. So area under an acceleration time graph gives us change in velocity, while the area under a velocity time graph gives us displacement. We will be solving questions based on this, but before that, let us understand how to figure out the sign of slope or the gradient of the graphs. When is the gradient positive, when it is negative? So please remember only the shapes of the graph. So if the shape of the graph looks like this, that means this graph has an increasing positive gradient. On the other hand, case 2, if the graph looks like this, then this is increasing negative gradient. Case number 3, if the graph looks like this is decreasing positive gradient. And finally, case 4, if the graph looks like this, the graph has a decreasing negative gradient. Now, in the exam situation, it will be very easy to solve the questions if you can just remember the shapes with the exact type of gradient. Now, it is a little difficult to memorize this. That is why now let us understand the general shortcut, how to remember the sign of the slope or the gradient. And what is the shortcut? The gradient is increasing if the graph is a upward facing parabola. So if you look at case number 1, this is an upward facing parabola. Similarly, in case 2, this is also an upward facing parabola. That is why the gradient is increasing in both these cases. On the other hand, gradient will be decreasing if the graph is a downward facing parabola. So in case 3 and case 4, you can see both of these graphs are parts of a downward facing parabola. That's why the gradients are decreasing. So this is the shortcut how to identify whether the gradient is increasing or decreasing. But how to check whether the gradient is positive or negative? So the shortcut for that is gradient is positive if the value of y increases as x increases and vice versa. Let's understand this with case 1. If you look at the shape of this graph, so watch, as the value of x keeps increasing, the value of y keeps on increasing. And that is why the gradient is positive. Similarly, in case 3, if you observe, as the value of x keeps on increasing, the value of y keeps on increasing. And hence the gradient is positive. And that is the shortcut for positive gradient. Gradient will be negative if the reverse happens. What is the reverse? Y should decrease as x increases and vice versa. So what will be the vice versa? Y should increase as x decreases. Let's analyze this case number 2. If the value of x keeps on increasing, so the value of y keeps on decreasing. That's why the gradient is negative. And look at case number 4. If you analyze this, as the value of x keeps on increasing, the value of y keeps on decreasing. That is why the gradient is negative. And these are the shortcuts which you need to remember while solving the exam questions. And now let's solve a question based on these principles. So here we have a graph which is velocity versus time, and we need to figure out the variation of acceleration versus time. How do we identify acceleration from the velocity time graph? So remember the basic logic, acceleration is the gradient of a velocity time graph, which means we need to analyze the gradient of this graph, the velocity time graph. And now let us label 3 different points. O, let's say, is the origin, A point on the top, and on the right, let me label point B. So we are going to consider the motion in 2 parts, O to A and then from A to B. Before that, let me write acceleration is nothing but the gradient of the velocity time graph. So from O to A, let's analyze that. O to A is a part of a downward facing parabola. Let's go back to the shortcut. Since the graph is a downward facing parabola, hence the gradient will decrease. O to A is a part of a downward facing parabola, and hence the value of gradient will decrease. And since the gradient is decreasing from O to A, that means acceleration will decrease. Now let me repeat. Acceleration is the gradient of a velocity time graph. And just now we have deduced that from O to A, the gradient is decreasing. So let me write, since the gradient is decreasing from O to A, that's why from O to A, the value of acceleration is actually decreasing. And if you analyze A to B is also a part of a downward facing parabola, which means gradient needs to decrease, which means from A to B also acceleration is continuously reducing. Now, if you analyze all the options, we need to check which graph satisfies these conditions. And the condition is from O to A to B, the acceleration needs to reduce. Option C and D are definitely wrong because acceleration is not constant, it is decreasing. So C and D are definitely discarded. In option B, you can see that the value of acceleration is increasing, which is opposite to what we require. We need acceleration to reduce. Hence, option B also is discarded. Hence, option A is the right answer. In option A, you can see the value of acceleration is continuously reducing. But in any case, let us also figure out the sign of acceleration. So we go back to the shortcut. The shortcut is gradient is positive when y is increasing as the value of x increases. So if you analyze the first half of the graph from O to A, as we are going from O to A, the value of x increases and y also is increasing. That means the sign of the gradient will be positive. So let me write here from O to A, the sign of acceleration needs to be positive. A will be positive for O to A. If you analyze the graph from A to B, as we are going from A to B, the value of x increases, but the value of y decreases. And going back to the shortcut, whenever that happens, y decreasing as x increases, gradient is negative, which means from A to B, the sign of acceleration will be negative. So let's write down A to B acceleration will be negative. Now let us analyze all of these deductions in option A. In option A, you can see that the first half of the graph is above the x-axis, which means acceleration is positive. The second half of the graph is below the time axis, which means acceleration is negative. So all of these conditions which we have deduced, acceleration needs to reduce throughout, and acceleration is positive in the first half and negative in the second half. All these conditions are satisfied only for option A. And that is why option A is the right answer for this question. And that's why I and that is why I said to solve exam questions very easily, please remember the shortcuts. Shortcuts on how to identify when is the gradient increasing, decreasing, and when is the gradient positive or negative. In this question, we have been given an acceleration time graph and we are supposed to identify the right velocity time graph. We are going to use the same shortcuts. But before that, remember the basic logic. How do we identify acceleration from a velocity time graph? And the trick is gradient for a velocity time graph that gives us the value of acceleration. Now, which of these four graphs corresponds to the acceleration time graph which is given to us? How do we do that? Let us analyze the acceleration time graph which is given to us. So first of all, let me break this graph in two parts by labeling, let's say O is the origin, point A on the top and point B on the right. Now let us analyze this graph. From O to A, you can see the magnitude of acceleration is continuously increasing, and from A to B, the acceleration is decreasing. So first of all, let us write that down. From O to A, the acceleration increases, and from A to B, which is the second half of the graph, acceleration decreases. But what is acceleration? Acceleration is nothing but the gradient of the velocity time graph. So from O to A, since the acceleration was increasing, we can write the gradient of the velocity time graph needs to increase. Similarly, from A to B, acceleration is decreasing, which means the gradient of the velocity time graph needs to decrease. And now we can use the shortcut. And the shortcut was, if the gradient is increasing, the graph will be an upward parabola. If the gradient is decreasing, then it will be a downward parabola. From O to A, which is the first half of the graph, we had deduced that the gradient is increasing, which means the shape of the velocity time graph should be an upward facing parabola. Now, since it is going to be a parabola, that means option B and option D can definitely be discarded because B and D are straight lines and we need parabolas as the shapes. So from O to A, since the gradient is increasing, so the shape should be an upward facing parabola, which is only there in option A. You can see this part of the graph, this is an upward facing parabola, but in any case, let me label O will be this point and A is this point. So O to A, this is an upward facing parabola, which means the gradient of this graph is increasing, which means the acceleration is increasing. So we are using a reverse tactic. From O to A, the magnitude of acceleration is increasing. Acceleration is nothing but the gradient of velocity time graph. From O to A, acceleration is increasing, which means the gradient needs to increase. And then we use the shortcut. Since the gradient is increasing, the graph needs to be an upward facing parabola. Now let's analyze the second half of the graph. A to B, the value of acceleration is decreasing, which means the gradient of the velocity time graph should decrease. Now, since the gradient is decreasing, now if we go back to the shortcut was, if the gradient is decreasing, the graph needs to be a downward facing parabola. And that is why for A to B, the shape needs to be a downward facing parabola, as you can see in the option A. So also let me label the point B over here. O to A is the upward facing parabola, A to B is the downward facing parabola. And that is why we can finally deduce option A is the right answer for this question. And that is how we deal with graph based questions. All you need to remember is the basic shortcuts. Shortcuts as in how to figure out when is the gradient increasing or decreasing and when the gradient is positive or negative.